Today we are going to see input buttons. Input buttons are very important in digital circuits. For example, see this. This is a digital clock and these are input buttons. You set a date, time or alarm using these input buttons. Similarly, see this is a portable speaker and these are input buttons. Play, pause, forward, reverse, etc. These are done using input buttons. So input buttons are very important in digital circuits. Now let's see how we use them. For that, take an LED, put it here, negative button grounded, that means cathode, and anode you can connect it anywhere. Right now let's connect it to pin 13. Now take a button, push button, put it here. One side will be grounded. You can connect it here and you can connect it here as well because both of these points are grounded. Okay, one side grounded and the other you can connect anywhere. Let's say I connect it to pin 7. Okay, now we are writing a very simple program. We will press this button and it will turn on the LED. Okay, go to code, select text. Okay, now remember one thing. Wherever you connect an LED, that pin will be input always. LED is connected 13, so 13 output. Sorry, not input, it will be output always where LED is connected. And wherever you connect a button, it will be input. Input pull up. So pin 7 will be input underscore pull up. Pull up means when it is declared input, it is also at high. Because you cannot leave any pin at floating. Whenever you make a pin input, it must be pulled up or pulled down. I'm not going to further details. Just remember that whenever you connect a button, you will make it input pull up. Okay. Delete these lines and put an if statement here. If digital read 7 is 0. That means whenever you press this button, 7 will be connected to ground. This is ground and this is also ground. So when button is pressed, pin 7 will go low. It will be 0. Right now it is high because we have declared it input pull up. It is 1 normally. When you press this button, it will be connected to ground and it will remain ground until you keep button pressed. So digital read 7 means you read pin 7, its state, and if it is 0, that means if button is pressed, then digital write 13 high. That's it. This is a very simple program. We will press the button, it will turn on the light, and that's it. Okay, it has started, and if I press the button, it will turn on the LED. See? Okay, now let's connect another button to turn off the LED. Okay, this is the push button. You need to connect this to ground because this pin is also ground. You can connect it here, or you can connect it directly to ground. Other pin you can connect it anywhere. Let's say we connect it to 3. Okay. So this one button is turning it off and this button will turn it off. Now we will modify the code. Just copy paste these two lines. Okay. This is pin 3. So if 3 goes low, then turn off the LED. Okay. and as we have connected a button to pin 3, that's why it must be made input. So just copy Control C and Control V. Now button 3 input, button 7 input, and these are two buttons. One will turn it off, other will turn it off. Now see, I pressed this button, it turned on the LED. I pressed this button, it turned off the LED. So now we are controlling the function of the circuit using input buttons. Now let's use one button to turn the LED on or off. That is a bit tricky, but let's try. Okay, remove this button. Now we are going to use one button. We press it one time, it will turn on the LED. We press it again, it will turn off the LED. Okay, so now we modify the condition. Okay, if digital read 7 is 0 and digital read 13 is also 0. This means if we press the button and LED is off, then turn it on. And this pin, if button is pressed and digital read 13, that means LED status is on. But if we press the button and LED is on, then turn it off. Now this program will work, but it will not be a very perfect execution. It will work sometimes and it will not work sometimes. Let's check. Okay, press it. Now see, it tried to turn on and turn off again. Okay, so it is working sometimes and sometimes it doesn't, but actually it is not working anytime. Okay, now let's see the reason. Reason is program execution. Execution flow is like this. First this line executed, then this line, and this line, and in the loop after this line it again starts from the start of the loop. And this execution is so fast that it is done in within microseconds. Now see, if we press the button, if this condition is executed, button is still pressed, this condition is also executed because it is very fast. There is no delay here and no delay here. If we introduce some delay, it will be a bit better but not perfect. Let's try that too. Now see, I put a delay here. Okay, delay let's say 250. Now program will stay here for 250 milliseconds, and here also delay 250. Now it will work a bit better than before, but not perfect. Okay, now let's see, I press it, on, off. Okay, now see, if I keep it pressed, it is working. Okay, let's increase the delay, make it 500 and try. Okay, still not working fine. It turns on and then it is turned off immediately. Sorry, here I didn't make it 7, that's why it is not working. Okay, make it 7. Okay, on, off, on. Okay. Sometimes it is working, sometimes it does not, and the reason is flow control, execution flow. If we modify that flow, it will work perfect. That is the main point. Now concentrate it very well. Okay, for that I am going to modify the flow control. Delete all this line, set a label here. I will explain what is the label. Start, put a colon, and here if digital read 7 is 0 and digital read 13 is also 0. That means if I press the button and LED is off, then put brackets and button 1, another label, and another if digital read 7 is 1, again brackets, and digital write 13 high, and after that go to start. Okay, now if we use button this way, this will work perfect. Now I will explain what is the execution. Now see, program will come here, then here, after that it will read the condition, it will enter. Sorry, I need to put here, go to button 1. Go to button 1. Okay, now if button is pressed and it enters, now until we keep the button pressed, this condition will be false. It will not enter this loop. Button 1 will go here, okay, because this block is skipped. It will just go here, and after that it will order it to go to button 1 again. It will come here again, here, 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 here. It will keep on revolving here. That means nothing will happen until button is pressed. When we release the button, it will be 7. It will come here, it will turn on the LED, and then it will go to start. Okay, it will turn on the LED and it will go to the start of the loop, and execution will continue. Now this is for turning on the LED, and we can use the same to turn off the LED. Okay, copy paste this if, Control C, Control V. Okay, if digital read 7 is 0, that means if button is pressed and LED is on, read pin 7 and read pin 13. If LED is on, then make it button 2 and go to button 2, and here make it low. Okay, so if this condition is true, it will come here under inside the if this condition is true. After that, if we keep the button pressed, that means 7 is 0, this condition will be false. This block will be skipped, it will come here, it will order it to go back to button 2, it will come here, here, here. It will keep on revolving here. That means nothing will happen until we keep the button pressed. If we leave the button, pin 7 will be 1, this condition will be true, it will enter the if, it will turn off the LED and it will go to start. Okay, so now this program is perfect. Let's check. On, off. So it will not be skipped even a single time. Whenever you press the button, it will work. It is working perfect. Now see, I am keeping the button pressed. Now button is pressed It will work when I leave. Until button is pressed, nothing will happen. I leave the button, now I left, it is on. Again I press, and when I leave the button, then it will work. So using this flow control, we can make a perfect button. Now see, it is not missing even a single time.